How's everyone doing? Thank you for coming to the February community call for Terraform on Azure. My name is Stephen Ma. I'm also joined by my colleague Mark Gray, as well as my other colleague who's joining us for the first time, Jingwei Wang. We're going to be going through some of our latest community updates, as well as having a special guest speaker for the first time. But before we get into all the details, as always, we have this code of conduct. We trust that you all are adults and that you will all behave and be responsible and nice to each other. Basically, don't be mean and you'll be fine. So always appreciate that. We'll give you another like 5 seconds to read through that. All right. So for today's agenda, we have a lot of things to get through. First, we're going to as always, start with an overview of these community calls. The first question that you automatically will think is, well, who the heck are we? If you've been here before, you already know this, but Mark and I, as well as Jingwei, are part of the Azure Deployments team. Our team's goal is to make Azure the platform of choice for every single IT, DevOps, and developer engineer that there is. We really want to make sure that we meet you where you're at with our solutions. And in order to do that, we've been working hard to continuously develop frictionless experiences through Azure. We work as a team on the Bicep, ARM template, and Terraform on Azure experiences, but we also have a sister team that owns CLI and PowerShell, and we work very closely with all of them. So why are we doing these calls? Well, there's a few reasons why. First, we value your feedback. Your feedback is what helps us improve our products, and we want to make sure that they're improved in a way that helps you do more. Second, we want you to be able to contribute into making your experience better. Third, we actually want you to even join us. We have a guest speaker today, but there's a form that you see right there. Please make sure to fill that out if you want to be featured on a potential future community call. If you don't have time to click on that, or if you're not able to click on it, it's aka.ms/aztfcc speakers. That'll be a form that will tell you everything you need to submit your community call topic. The only ask that we have is that you are a member of the community, and if you're not, that's aka.ms/Azure Terraform to join that. The last thing that I wanted to talk about is learning. We just want to keep you up to date with all of the different updates that we've been bringing to our products and our investments to ensure that you have a great experience. And in regards to that, one of the things that we're going to start doing is a bi-monthly update. Bi-monthly, by the way, is not every 2 weeks. It's going to be every other month. Why are we doing this, or what are we doing here? Well, first, this is supposed to be a one-stop shop for us to really put out all of our Terraform on Azure changes. The hope with this is that you get every single piece of information that you might need to know what's the latest and newest that the product team wants to feature within your Terraform on Azure experience, all within a read that takes less than 5 minutes. This will be on Tech Community blog. We're planning to have our first post this week, and yes, you, the community, are the first people to hear about it. So be on the lookout for that. It should be released sometime later this week, and we're always going to try to iterate and carry your feedback through that as we go. So that's everything for the community portion. Next, I'm going to have Mark come up and talk about the AZ API provider.
Hey everyone, as Stephen mentioned, my name is Mark Gray. I'm the principal program manager that works on Terraform. So to extend on what Stephen mentioned there, we essentially anything to do with Terraform on Azure is what our team focuses on. So we spend a lot of time on the Azure RM provider, but we also work on tooling to make your experience better in using Terraform on Azure. So I'm going to spend a few minutes here today. We've talked about the AZ API provider a number of times during these sessions. I'm not going to go into a lot of details on the AZ API provider. It's in our Microsoft documentation if you want to learn more about it. But I'll give you a quick overview here and then talk about something where you can help us make it better. So essentially, the AZ API provider is a provider that allows you to manage anything in Azure, and that means anything in Azure. So it's not intended to take the place of the Azure RM provider, but the primary feedback that we get from customers is that they want to be able to do everything in Azure with Terraform. So they choose they choose Terraform as their infrastructure as code of choice, and they want to be able to manage all of their infrastructure using Terraform. The Azure provider is something that most customers use. It's the HashiCorp provider, and it covers the vast majority of things that you would want to manage in Azure. But there will always be things that you can't manage. A couple of good examples of those are things that are in preview. So be it private preview or public preview, those typically are not covered in the Azure provider until those things go GA. So the AZ API provider gives you a good way of managing those things, as well as there's support for actions. So if something doesn't have state, but you still want to manage it through Terraform and you don't want to use a local exec, if there's an API for it, you can do it in the AZ API provider. So it's an incredibly powerful provider, and still maintains all of the goodness that you're used to in Terraform. So it has state, and gives you the ability to manage all of that stuff. There are a couple of additional tools that we provide with the AZ API provider, the VS Code extension. So we didn't want you to have to look at REST documentation to understand what you need to pass to configure things in Azure. So the Visual Studio Code extension allows you to very easily get IntelliSense and underlining and all of that stuff, so that you can very easily add the properties that are required and the values that are required for those different calls. The other thing is a migration tool. So we do expect customers to, you don't have to, but we do expect there will be scenarios where customers will want to move from the AZ API provider to the Azure provider, and we provide a tool that allows you to do that. So it streamlines the updating of the HCL file as well as the state. So you can very easily move to Azure RM when the functionality is included in Azure RM. So if you want to learn more about it, go to the docs on Azure for Terraform, and we have some good information to get you started there, and learn more about it. So what I really want to understand, we've had a lot of conversations with customers since we've released the AZ API provider. We've got mixed feedback on it. Some customers love it and want to use it a ton. Other customers want that functionality to be in a single provider, which is really not feasible. But we'd love to hear your feedback. We've heard anecdotal feedback from customers here and there that we talk to, but we'd love to learn more about if you use AZ API, why you use API. If you don't use AZ API, why you don't use AZ API. So we have a form here that you can fill out and let us know more information about why you do or don't use AZ API provider, and it will help us make the provider better and make it better for you to use Terraform on Azure all up. So that is a quick link there. So if you don't have time to click on this, we will publish the deck after the session, but it's I'll give you a minute to write that down. So please do fill out that survey. We really do want to hear from you. And I will turn it back over to, is it Stephen, or do I turn it over to, all right, I'll turn it back over to Stephen here.
Awesome. Thank you, Mark. We're going to talk about the export tool. You might have known this tool as Azure Terraform in the past. Just a quick overview about the tool first. We really designed this tool originally to move your existing your existing Azure infrastructure into Terraform state, as well as generate HCL code from it. But as we've continued to develop this tool, our goal has become a little broader, but a little more ambitious, which is to convert and translate all of your Azure concepts with your Terraform concepts, such as resources and state and HCL code from your Azure traditional infrastructure. The import source was historically just a resource group, but nowadays you can use both. You can use the tool both on a resource group and a subscription. And the whole idea of the workflow is that you can choose to either import your state or not, but you will always get your HCL code generated from the tool. And there's a ton of different scenarios for this tool and a ton of different ways that you can use it. And one of the ways that we're trying to help with that is that we are currently working on comprehensive documentation. But another way that we try to help you as a community understand that is by bringing in fellow community members. And that is where we're going to introduce Jeremy, who is our friend who's going to be joining us today, as well as one of our community members who will be talking about his experience using Azure Terrify to help him in his scenario. So I'm going to hand it over to him.
All right. Thanks, Stephen and Mark. Well, as I said, I'm Jeremy Myers, and I'm a cloud architect at Weyerhaeuser. And something that Stephen said really resonated with me was they're attempting to meet us where we are, right? So we have environments that have been living out there for years before we got here. And some of those environments need to be brought up to spec, up to standard, either with new security standards or best practices around CI/CD and IAC, but we have to deal with them anyways. Our newer modern landing zones are all built with code via pipelines and CI/CD, but how about the skeletons in the closet, right? We need to bring those forward as well. They can't continue to live and be supported manually through the portal or through some other resource. So what I want to share with you is how we're handling some of that, right? It's not all easy. Some of it takes a little bit of work, and some of the reasons that it is the way it is. There's older services that were built before Terraform really kind of exploded, and surely before we adopted it and started using it. Those are out there. There's resources that were deployed not using good standards that we would prefer to see at this point. And there's environments that were deployed by third-party resources, right? You bring in a company to help stand up something, and they build it, hand it over to you, and you got to continue to support this, but they aren't around. And potentially, I mean, I don't run into this too often, but occasionally you run into a situation where there's a lack of documentation, right? Or a good architecture diagram that explains how this system works, how it was meant to be used, and how it's configured. The other piece is time, right? So we're all expected to keep the lights on, keep the business going, and moving forward through business innovation projects, and then of course our enterprise initiatives for upgrades and new services, new ways of doing things, enhancements for our development and app teams. And so time just slips away from us, and we don't have all the time we need to go back and figure out how those things were architected. And as Stephen said, they're looking to meet us where we're at, right? We have modern landing zones that are deployed with code. We have legacy environments that are just deployed. We don't know how or where. And here's Azure Terrify, lands us in the middle, right? And we're using that to point to those legacy environments as we get time, beginning to chunk this away and figure out what that configuration is using Azure Terrify. As they mentioned, it'll attempt to interpret the current configuration out there and convert that into Terraform for us. And we can point that at a subscription. In some cases, we've used it for against resource groups, everything within there, or just specific resource lists. If we wanted just certain resources, I'll show you how we can do some of that. Interactive and automated, either way, really just amounts to whether you're getting prompted to what you want to actually do. And so most times I run it non-interactive because I'm pretty confident with what I want to do. We get the state each time, and we take it a step farther, and I'll show you that in just a little bit. We push it to a remote state. So if you're using Terraform, you're using state probably in some way or shape, and that's why you're using Terraform, right? So you're pushed to a storage account or a bucket, or you're pushing to Terraform Enterprise or Cloud to manage that state, through collaboration. This thing is so easy, even I can do it. And if you know me, you know I'm not a developer. I'm a pretty good scripter, but not a developer. And even I can do this, and we'll do this here. So our first use case that we used it for was fairly big, actually. The network team came to us on a Thursday morning and said, we would like to update a CIDR range across the entire network. So our, think VNets, subnets, and SGs, and we need to get that out by Monday, end of day. I have no idea what the impact is. All that environment was deployed manually through a pipeline, but it's still manual. There's no history to it. So We used our trusty AZ CLI to run against all of our subscriptions. In this case, it happened to be 6 of them that we needed to focus on as they hold our networking stuff. And it brought down about 260 locations or resources that might need updated based on the CIDR range that we were given. So I could write a script that would manually update those NSG rules to allow for the new CIDR range. But what about a rollback? How am I going to handle a rollback if that breaks, if I can figure out which one it broke actually, right? There's not a good way with Azure CLI. It's kind of a run it and it's done kind of thing. Surely you could build in some handling and some logging and things like that to revert it. But generally speaking, there's no good way to roll back. Well, here comes Azure Terrify, right? I said, let me take this manual environment, this legacy environment that doesn't have any Terraform for it. Let me see if I can pull it into Terraform and then into a repository to have a source of truth that I could roll back to, right? That's kind of how this works. And so we did. And it took about 6 hours for it to run. It's single threaded. I've attempted to run it in different terminals, and I've shared that with Stephen and Mark, and we're looking more into that. But it took about 6 hours. And in the end, it showed me I was going to impact about 600 resources, which is different than the 260 because it knew exactly which resource it was going to update, right? In the end, we had about a little over 1,700 resources codified in Terraform after this. A little over 32,000 lines of Terraform. And what I'll say is we all know that we can write pretty elegant code. This is very plain. It writes that each resource is its own block of code, where we know we might do a for each over some things. It doesn't do that yet. We're waiting, we're wishing. It's in the wish list. And so this 32 lines of code, 1,000 lines of code could probably be significantly shorter, but that it is what it is to start with. So we committed that into our Git repository, right? And now I could run a plan against that code and see that there was no change. The code that it pulled down matched what was out there. No change. I'm even set. I could apply my change now, commit that, see a Terraform plan, see the impacted resources, validate with our networking team and our project team. And then on Monday evening, I pressed the apply button and all those resources were updated. Very, very simple. But a huge impact to our environment. At this point, everything going forward in terms of NSG and subnet and VNet changes goes through Terraform. That's because of Azure Terrify. I couldn't have wrote that myself in several sprints worth of time. I know, but it's all under control now. And security loves it. Our governance loves it. Our team loves it because we've trained others on how to use it, and they're now able to help manage requests that come into that process. So that was pretty cool. The other one was through a complex Azure firewall configuration, and really not that complex, but for me, not being a firewall guy, it was different. It was something I hadn't worked on too much. So basically the ask was, we have a vendor that needs to talk to one of our internal VMs as a mode of support. And security required that we go through a firewall to do that. So we got that set up. We had a static public IP that the vendor can make calls to. We DNATed the internal IP so that the IP of the VM would be DNATed off the public IP. We had route tables to show next hop. We had to restrict access to the vendor's IPs. We needed to restrict ports and protocols, just like we do with any other NSG, to meet security standards, right? To really lock this thing down and make sure it's secure. Well, this took about 2 days to manually set up in the portal. Didn't have a good grasp of what we were trying to get to. Lots of debugging with the vendor, our app team, review with security, review with my team. In the end, after 2 days, we got this thing working finally, and I learned a ton. Now, do I remember everything I did to put it into Terraform? Not likely. It was 2 full long days of really making a lot of configuration changes and adjusting these rules and next hops and things like that to make the calls work. Well, point Azure Terrify at the resource group I created and the resources that I had built. Took it about 2 hours to, it didn't take 2 hours to run. It took about 20 minutes to run. I needed to make a few minor code modifications to that to update it to our coding standards and use some variables, which they're looking into as well. But at the end of 2 hours, it was completely ready. I checked it in, I ran a plan, and it was good. No change based on what was already there. This is perfect. I didn't have to write a single line of code myself. I had built it manually in the portal, got it working, exported it using Azure Terraform, and then committed that into my code base, and I was ready to go. There wasn't any need to write any additional Terraform at that point, just adjust it and make it look pretty and meet our standards. So that was really cool and nice for us. I'm ready for production at this point. I just point that environment at our production subscription, and that code that was pulled out for dev is now going to production. So that's really cool. So thank you guys for your hard work. You're saving me a lot of time. So let's look at a little demo here, right? I've done some pre-work, but we're going to run some queries here to kind of see what they look like. And what you see in the bottom left is a small screenshot of the resource group that I created. It's got 10 resources in it. It's your typical app, web app service plan, database server that it's running on, some app insights for monitoring. It's got the VNet. It's got the NIC for the VM, the SQL server. It's a DNS zone that it needed, and a storage account. That's pretty typical and standard for what a web app might look like, right? Now, if we scale that, there'll be duplicates and redundancy in different regions and things like that, but this is what it might look like. And so I'm going to use the first one. I'm going to point at this resource group, which happens to be called Modern App, and I'm going to use the non-interactive command so it doesn't prompt me, and pull down the resources in there. And what we see here are 10 resources. Let's see what Azure Terraform finds. Okay, we'll look at that in a second. The second one there is defining resources. So if you want to only pull down something like just the SQL server and have that in a separate state and a separate configuration, then the rest of your stuff, you can really pinpoint your services to allow it to segregate services based on maybe who owns them. So the DBAs want to own their servers. I'll pull that information out separate kind of thing in this scenario. And lastly, like resources, I may or may not have used this one a little bit in a previous example, but I wanted anything related to a virtual network. I wanted VNets, subnets, NSGs, ASGs, anything around the virtual network because I needed to manage and make a change to that. And so it wouldn't pull down things around the virtual machines or storage or anything. I needed to keep this state very clean and concise to just virtual network type resources. So that's another option you can use. And I did each one of these against this environment, and I'll show you the result for that. So let's bring up VS Code. All right. So we'll get rid of this and let's go rid of this. Okay. So I'm in my AZTFY reactor demo, and we can see there's nothing in that folder at this point. So let's go ahead and run this command. So AZTFY, give my resource group as the short, non-interactive, modern app. Let's go ahead and run that guy. And we'll give it just a second. We're not going to sit here and wait because it does take a little while, and it's for good reason. You'll see in a minute why. I want to hang out just long enough to see why. But this is going to run, and it's going to pull down the interpretation of this web app resource group that I showed you that had 10 resources in it, right? And it's going to give me all the files necessary to run a Terraform plan immediately afterwards and get a no change. I'm going to take it a step farther and initialize that into a Terraform Cloud workspace, like most of us probably would, or enterprise, to manage that state there. Now, you could obviously push that out to a storage account, S3 bucket, or whatever it might be that you're using to manage your state. But either way, you get the state file that you need to push that. And we're going to talk through all the different steps. I say, there's 7-ish steps it takes to get from this point into that managed workspace with Terraform Cloud. So we'll give this just a second. Let's look at the resource. So when I ran that resource, I pointed at a specific SQL server, right? This is what I got back. There's one resource out there that is of the type SQL Server for this ID. So it brought back everything I needed for that. That is the Terraform. That is the provider block for you. Note the backend is local. We're going to change that in a little bit. And here's the state. You can't read through the state very well with these because they get pretty big pretty quick. But this is actually everything you needed to go and redeploy that resource. Here we go. It's going now. Let's take a look back here. We had 10 resources in that resource group. Terraform actually finds 201 resources. So there's a lot more to these services than just a single Terraform resource, isn't there? And this would take you a lot of time to build out manually to get everything you need, everything from app configurations to database configurations to VNet settings, and what else is in there? The NICs and the network IPs, the DNS zones, and the different configuration settings for that. It would take some time to build this out manually. And what I'll say is this takes about 5 or 10 minutes to run in the background, and I'm going to kind of just walk away from it for now and come back to the one that I've already run for us. And that's this one, the Azure Terraform demo. And we'll see, here's our main. I'm going to pull this down for you. And you can see off to the side, there's a pretty good amount of code in here, isn't there? Here's our resource group, modern app, and all the network interfaces and the DNS zone, and goes through all the services. So that's great. Here's our provider. Note that I changed the backend from local to a cloud, and I'm going to show us how we can initialize that and push it over. Here's our state backup, the resource mappings, so that if you say, hey, this resource should actually be mapped a little differently, or I want to change the name of it, you're able to do that as well. So that's very handy. But this is everything you need to get this into working Terraform code. Note, there are some skipped resources there, and that might be because maybe there isn't a Terraform provider module for that. So there may not be a resource for that. And that's where the AZ API comes in handy. And I've really been leaning on that a lot lately, because in scenarios there is a good resource for it in Terraform, but it doesn't handle all the latest parameters that are available to us. And so I'll create the resource using Terraform or Azure Terraform to give me the block, and then build it with Terraform. But then when I went on to make updates to those parameters that are just not available, I can use the AZ API to go ahead and finish that configuration the way I want. And I'm happy to hear that they're making a tool to convert that over, because that is something that sits in the back of my mind as a little bit of tech debt at some point. But for now, we're not too worried about it, because we have a way to cover that gap, which is really handy for us. So let's go in here and let's take a look. Let's see. Let's take a look at our provider block. If you're familiar with Terraform, you know you can set it back into cloud. I have my organization reactor demo set up. It's pointed to the Terraform cloud. It's got a workspace. And let's call this one live demo. And what I'll say is this doesn't exist yet. There is no workspace for this as of yet, right? So we're going to create this, but I'm not going to do anything in the Terraform portal. Let's just, TFC is my abbreviation for it. So let's do a quick init. Okay, cool. And now that we've got that there, let's go ahead and push this state, right? You gave me a state to manage. So let's go ahead and push that up there. And let's use the state. Let's use the backup file here. We initialized this. This connected us to the Terraform cloud in the back end, right? And if we go and look, it did, in fact, create us a nice workspace. Let's do a quick, oh, I know where it's at. I didn't need to refresh. It went into the default project. It's right here. One thing I know is I'm going to need a way to log into Azure to actually run this thing. So I have a variable set pre-created, but that'll be something you'll figure out how your team's going to do. Let's go back to here. Let's go ahead and push that state. TFS, yeah. Slightly older repository system. Let's go with TFC for Terraform Cloud. And it's going to push that state up to my workspace at this point. Now I can do a TFC plan. Now what I should see is a no change, right? I just pulled this down using Azure Terraform from the cloud, or from Azure. I pushed the state out there and I'm running the code. I haven't made any changes to the code, but I did make a little change because there was a hiccup in one of the resources and how it's being configured. But that's okay. It was a alerting monitoring that I set up that I should have just uninstalled, but that's okay. So I just commented out. So it's going to show as a change. But otherwise, I get a no change out of this. And at this point, I could commit this code to my repository and set the webhook on the Terraform workspace to run based on changes in the repository to a commit, right? So when we commit things or merge things into master, go ahead and run the Terraform plan. I didn't have to really do anything in terms of writing Terraform because Azure Terraform did it all for me, right? It gave me the state file to push to my workspace to be managed by Terraform Cloud. So if I switch back over there real quick, I can now look at runs. I can look at states. So there's my state that I just pushed up a minute ago, right? Everything I need is in Terraform or managed via Terraform Cloud for the state now at this point. So this is really super easy to use. If you're not using it or haven't used it yet, I definitely recommend you go out there and give it a shot. Let me go back to my PowerPoint real quick. And just to, yeah, so we're about 46, 49. You can see it's jumping pretty quick of 201 resources. So like I said, it takes maybe 5 or 10 minutes to run. You're talking about 10 minutes over 201 resources. Tell me how long it take you to codify that. The value is still definitely significant here for us. So what I did to make all this work real quick, kind of quick review, things you didn't see. AZ login. I had to log into my Azure subscription in the back end, right, from the AZ CLI. In order for the Azure Terraform to see that subscription, I set my account to my subscription name, and then I ran that Azure Terraform command, non-interactive modern app. Then I modified the generated provider to include the cloud backend, right, to point to my org and workspace. I did a Terraform login, which you didn't already see because I had already gotten the token. I did the init, I did the state push, and then I ran a plan. It can't get any easier than this. Well, hopefully you guys learned something today. And thanks, Stephen and Mark, for having me. And feel free to reach out to me on LinkedIn, Jeremy J. Myers. I'm on there if you have questions or ideas, a better way to do this. I'm always looking for a better way to do it. So thanks, Stephen.
That was the greatest end-to-end demo I've seen by anyone outside of us with regards to Azure Terraform, and really couldn't have asked for a better gold standard setter for our first community member to help demo and participate at the call. We have a few more updates about the tool before we move on to the next section. So first of all, we recently finished another user study. Thank you to all the community members who filled out the forms to be contacted for that. We got some great feedback that we are planning to iterate on with our next release, and we're hoping that that can all happen in March. In the meantime, we are also drafting those aforementioned documentation around scenarios that really can help you be set up for success with the tool. These are just a few light updates, but by the time that the next call comes around, I'm sure that we'll have a lot more comprehensive details that we can talk to you about in terms of the changes we've made. And before I end this section, just one more thing I wanted to talk about. Some of you in the community have given feedback on the name Azure Terraform. Rather terrifying. So instead of moving with that name, we have gone through the process of getting that name changed, and we are happy to announce today that the new name for this tool is going to be moving forward, Microsoft Azure Export for Terraform. I leave it up to you if you want to call it Nate, or if you want to mess around with that however you wish to as an acronym. But we're excited moving forward. You should see on the GitHub and on the documentation that eventually gets released these changes reflected, as well as some changes to the binary names and packages. So be on the lookout for that. We will try to keep you as involved in that process as possible. And next, I'm going to turn it over to Jingwei, the third PM on our team, who is going to talk about the Azure verified modules. Take it away.
Hey, hello everyone. Can everyone hear my voice? Okay, thanks. I'm Jingwei. It's actually my first time to present here, and it's really my great pleasure to introduce the Verify module section to all of you. I'm now working with Mark and Steven on the Terraform implementation in order to give you a better user experience. And just for your notification, not only PMs, but also our engineering team are in this community call as well. So we might then work together and have further discussions if you have any inquiries later. Steven, would you help move to the next slide? Thank you. So before we actually get started, I assume that every one of you might be quite curious about why we are using the Verify modules. The Terraform modules might not be a very new concept to all of us. It is actually a set of Terraform configuration files in one single directory. In one typical module, we might have one license, we might have one README markdown, the main TF, the variable TF, and the output TF, and so on. However, although we have lots of modules in the Terraform registry, some of them have some potential problems that might hurt our RD work. For instance, there's currently no very clear module development standard that we might totally get lost about how a good module would be looking like. And we also see that for some similar business scenarios, there are always some duplicated modules existed, and we might get very confused in our current development work. Also, due to the unclear development process of the modules, there might be some inconsistencies across different modules and might cause some interruption in our infrastructure. Another significant problem is that many of the modules are not well maintained, upgraded, or functional anymore. So we also see some problems that some modules are mainly targeted for your day one's deployment, but totally ignoring your day 2 to day 100 following maintenance work. So to help tackle those issues, we have established a new testing pipeline. All the modules that have passed our testing pipeline will be marked as verified modules. This pipeline really benefits our engineering work, as we finally have a place for the centralized management and the maintenance of the modules. And we will try to empower the do not repeat yourself principle. We will always ensure the consistency among different modules, make sure that they are always functional. We will try to ease your daily maintenance and upgrade work. And we will also allow the open contributions from the wider community. Sorry. Meanwhile, we will also make sure that all the modules released have very targeted business scenarios, and they are actually urgently required by the customers. Steven, would you help move to the next slide? Oh, thank you. So then I want to talk more about our current module list and our future plans. We can see that we have in total 8 released verified modules, like those related to compute, the network, and load balancer, etc. These modules are mostly transformed from the legacy ones into the verified ones by our engineering team based on our initial customer interviews and data analysis. We have referred to the module usage conditions and the download conditions, the GitHub stats, the request for commands from other cloud services providers like Google and Amazon as well, to initially choose which ones we would like to firstly transform. Another highlight I want to specifically mention here is that we are now working with other engineering team in Microsoft on a module related to hub and spoke. Actually, this collaboration mode is what we really want to build among our team. We will really value your contributions, as our own efforts might be quite limited, but collectively we can make a huge difference. So I will talk about this whole contribution process later on in more detail. So back to our future plans for the verified modules to be released. We will try to commit to the general rule that we will release the verified modules that are really needed from the following perspective. First, we will check our development community to see what kind of modules are most popular by referring to some metrics. And we will also conduct some analysis on the telemetry to identify the most commonly used combination of resources. And we will also hold some regular customer interviews, which we would really appreciate if you are interested in being one of our interviewers. And we will refer to the best practice from other cloud services community. Another point is that we will try to catch up with the trend to see the Azure resource providers with the highest popularity among users, like these days OpenAI that have attained great attention from the world, to see where we can integrate them with Terraform modules and simplify your whole deployment process. Finally, I want to share with you about how we can contribute to our verified modules community. Please note that we only accept new verified modules from Microsoft employees at our current stage. But we will welcome all the pull requests and the patches to the existing verified modules from the wider community. As long as you agree to the Microsoft agreement, you can make some PRs to our verified modules registry. The left flowchart is our whole contribution process, but I won't elaborate them in much more detail. You can see that I have posted our codex, the modules repo template, and the contribution process markdown file on the right for your references. You might find your desired information from those documentations. Basically, the process is that you first, you can see from the left flowchart, you create your GitHub repo by referring to our module template and the codex. You can then conduct the pre-commit process to format your code and synchronize your dependency. And then you can make some tests in your local environment, like making a pull request test to perform the link check, the static check, and code policy check, and so on. And then you can just make a pull request to our repo, and you will go through our 2 code reviews process. And finally, if there's no other problems, we will merge it in our repo and release it. So that's the whole process of contributing to the verified modules community. So finally, I'll be very happy to introduce a verified module demo to introduce how in reality we can call a verified module and its benefits. This work should give great thanks to Zijie and Jiawei from our engineering team who have greatly contributed to this project. So we can, I have already made a recording in advance. Sorry, Steven, there seems no voice.
Sorry about that. It looks like we have audio issues, so give me a second. I'm going to try to see if we can figure this out.
Okay. Thank you.
Hi, team. It is really my great pleasure to present you with our verified modules. As we have discussed above, we have already created an official GitHub repo for you to see our list of verified modules. To see more detail about one specific verified module, please click on the README Markdown. Today I'm going to take the Azure RM Network Security Group, a popular verified module, as an example. The process of calling this module or using it in our configuration file is quite simple. We strongly recommend that you start from the examples we have provided. You can simply copy and paste it in our terminal like VS Code. Please remember to type in the provider like Azure RM, the resource Azure RM resource group, and the module network security group. This is the content that I have already pasted, and please do not forget to change the name of your resource group, like we have the NSG demo group here. Then we can simply type in the Terraform initiate in our terminal to get started. Then we can type in the command Terraform plan to make this implementation in your infrastructure happen. It will take like 15 to 20 seconds. We can see that we are going to create 4 resources: the new resource group, the resource group NSG, the network security group NSG, and the network security rule predefined rules. Then we can just type in the Terraform apply if we are conformed with those changes. We can see the specific information of those the resources one module contain, our compulsory and optional inputs and outputs here. We only type in the compulsory inputs here for simplicity, and you can add more inputs to make it more compatible with your own unique requirements. So let's get back to the VS Code. We can see that to create multiple resources with complicated properties, we only write down fewer than 40 lines of code. And it will take much greater efforts if you want to implement those resources one by one. So this really demonstrates the principle of reuse of configuration, that everyone has similar requirements will benefit from the hard work of the verified modules provider. So this is the process of using calling verified modules and the benefits of using them. Thank you for your attention.
Thanks, Jingwei. All right, so now we're going to finish things up with what we have promised, and we're going to show you an open source project that has to do with Terraform and Azure. This one doesn't have to specifically do with Azure, but we thought it was a cool project to highlight. It's not something we necessarily endorse. It's just a good project that might come in use for you as you're using Terraform with Azure. So what we're going to talk about today is an open source project called Infracost. Infracost is open source, but they have a paid subscription part as well. But all of the functionality I'll show you today is all open source. And we'll talk about the command line experience, but for those of you that really want to use it in the real world, I'll show you real quickly the GitHub Actions process as well. This is a really cool project that actually gives you visibility into the cost of your infrastructure at the time of your coding. So you don't have to make any changes to your environment. You just run infra cost against your infrastructure as code, and it'll tell you the total cost of your infrastructure. But you can also see deltas as well. So if you make changes to your code, you can see what the cost differential is, which is pretty powerful and pretty good. So it gives the infrastructure admins the ability to see kind of what impact their changes are going to have on the bottom line, essentially. So with that, I will jump into a short demo here and show you both the command line and the GitHub Actions. All right. So with this, I just have a project here. It's a Terraform configuration. I have a whole bunch of different things in the configuration. Essentially, I have some Kubernetes configuration here. I've got my resource group that I'm going to put all of these things into. We got some databases that folks are going to actually store their state to that are using Kubernetes. And then we just have some random names to make things easier, and then the networks that are going to be needed for this infrastructure. Then I just do some outputs and pass some variables in there. So pretty simple, straightforward configuration. And if I come down to my command line here and run infracost and do a breakdown for path, this will go look at my configuration and tell me exactly what the cost is for that configuration that I'm going to deploy. So it takes into account all of the paid things that you will have to pay for to deploy this. Things that have fixed cost, so fixed hourly cost, it'll give you that information. If there are things that really depend on your usage, it'll tell you approximately what it'll be per gigabyte. So it gives you some good information there. And then down at the bottom, it gives you the total cost that it's going to be per month. So it gives you really good information about your cost for deploying this infrastructure. You'll also notice down here that it tells you kind of a summary of what the costs are. So these things are things that were usage-based, and then there's some free things as well. If you want to see those free things, you can actually take a look at those as well by adding the show the skipped items as well. So that will actually show you all of these things in your configuration that you have are free, and they won't cost you anything for usage or kind of overtime or anything like that. So you really get a good picture of what your configuration is and what it's going to cost. The next thing I'll do is kind of make a baseline and make a change to my configuration, and you can kind of see what the delta is going to be when you make that change. So I'll start by making a baseline of this configuration, and that'll just save. Oops. I got to make the baseline first. All right, so this will actually show the skipped and make the baseline. So that will save that baseline to a JSON file on the desktop here. So you can see that it saved all of that information that I was showing on the screen before, but saves it as a big JSON file. So now I can actually run my compare on that. And this will show me exactly what the delta is if I had made any changes. And because I did not make any changes, you can see that there's no delta. So what I'll do is come into my Kubernetes file here and make a quick change. So I'm going to change this to 4 node count, and I'm going to change the instance type to a D4S v3. So if I go ahead and save that and then run my Delta again, you will see that it will give me a good breakdown of my terminal. What the change in cost is going to be. It gives me exactly what changed, what the delta is going to be for that change, and then it gives me the total month change. So it's going to increase my cost per month by $530, and it's going to be a 180% increase. All of that is really cool to kind of play with it. But let's take a look at what it looks like in the real world and when you're using Git to actually do those changes. So here I have the configuration that has been pushed up. It's the same configuration that I had before. So it's got, so here I have my GitHub repo that has a demo. I have the same files that I pushed up there. So if I look at my Kubernetes configuration, in here you can see it has the node count of 1 and my DS2 instance here. So it's the old configuration. Now if I come here and do a git add and do a git All right, so that was a terrible description, and I apologize for that. But in the matter of time, I'm just going to do a push up to a separate branch there, and then do a pull request into the main branch and show you the delta there. So if I do a git push here, and set the upstream properly. That will push up to my branch. And now if I go back to my code here, you'll see that I have the ability to do a PR. And if I do that PR, just create the PR, it will go through and run the infra cost and give me a delta in the comments in the check-in in the PR, so that whoever's looking and reviewing the PR can look and see if that cost is within budget and be able to approve it that way. So it really does give you some nice visibility there. It does it in a nice table, so you can see what it was, what it is now, and the delta there. And if you look at the details here in the output, you can actually see all of the details that you saw in the command line. So you can see the free resources and all that as well. So it gives you a really good integration with costs from your Terraform infrastructure. So I thought that was a pretty cool tool. So I thought I'd share it with everybody.
All right. Sorry, give us a second. Awesome. All right. Thank you, Mark. That's a pretty cool tool. I'm sure a lot of you will be looking forward to the money that you'll be saving. We now have the Q&A portion of this entire time. Sorry. Looks like I'm having issues. Let me reshare this. So you have the Q&A portion of this community call. So if you have any questions, please ask them in the chat right now. And we'll give it a couple minutes for people. I will be monitoring the questions on the side, so feel free to ask. We're both here. We promise we haven't left. All right. For time's sake, since we're already over time, we're just going to move ahead. And what we will do is please feel free to reach out to us if you ever have any questions. So in regards to learning more, as for always, AZAPI is on Microsoft Docs as well as AZTFY, which we are not going to change that binary name in the near future. For support, there's a few listed options here. You can always feel free to call Microsoft support. You can go to the GitHub, or you can contact us, the product group. We'll be sending an email out once with the bi-monthly update gets completed and published, so that you can make sure to have a direct link to that. And we're also going to be active on Twitter about that. So make sure to join the community so that you can get those notifications. And then feel free to also give us your feedback through the Azure Terraform GitHub, as well as follow us on Twitter. And as always, join the community. Thank you, everyone. Hope you enjoyed today's call, and we hope you have a great rest of your day.